Okay, so let me get started here. What I want to do is just to fill in a few things, maybe show you some more examples about vectors. I'm not going to provide any new information here in the video that isn't already in the soft chalk lesson. So let's kind of go ahead and get into it. So one of the first things we deal with a vector, since it's something that has a magnitude and direction, is that we can do some arithmetic with it. Okay, so you can have two vectors and you can add them up. All right. Now, whenever you're adding up vectors, what you want to do is think like you're walking a path. All right, so let's look at this first example then. So I've got A plus B plus C. And so what I'm going to do is I'm going to go in the direction of A. All right, so as if I walked that path. Then I'm going to walk the path of B, which B is just straight up. And then I'm going to walk C, which is over here like this. Okay, so the result of A plus B plus C is this guy right here. And we might, for example, call that R for the resultant vector. Okay, and if we wanted to make our picture nice, we might put A and a B and a C. Okay, we want to draw a little arrow or a little line over the top of them so that we know we're talking about the vector quantity and not just its length. If you don't put the line over the top about it, you're just talking about its length. Okay, so there's A plus B plus C. All right, so let's come in here. Let's take a look at another one. So the next one is 2A plus B. And the way you do that is just really what it sounds like. I'm going to do two A's. So here's one. Here's another one. So I just put them, line them up like that. Plus B, which brings me up here. Okay. And then start to finish. Here's my resultant. There. Okay. We could do some others here. Let me just move these out of the way. So I'll put that up there. Okay. And C comes this way. Kind of long. And then it says minus B. And the way you think about this is that when you're subtracting something, you're really adding a negative, right? So when we have a negative on a vector, we just invert it. We just reverse its direction. So B, instead of going up, we're going to do minus B, which goes down like this. Okay. And then start to finish right there. There's my resultant vector R. Okay. And let's get maybe one more of these. 2B minus C. Okay. And again, like we saw before, I just got to do two of them. Okay, so I go up twice, 1, 2, and then minus C. C is normally to the left, to the right, sorry. C is normally to the right, so I need to go to the left. And so I'm going to add that on over here, just like that. And then start to finish. There's my solution there. Okay, so pretty straightforward, just like that. Okay, this is what we call geometric addition, okay, or we're just using geometry to perform the addition. It's very limited. There's not a lot that you can do with this, but it kind of helps you get an idea of what we're doing when we're talking about vectors. All right, so here's an example. On a routine flight over Iraq, a surveillance drone flies east 10 miles, then south 5 miles, then west 5 miles, then north 10 miles, then west 5 miles, and finally south 5 miles. Well, we got a bunch of vectors here, okay? So every single one of these is a vector. Direction and a magnitude, direction and a magnitude, direction and a magnitude, okay? So all we need to do is put them together. Okay, and see what happens when we do that. So I don't have any marks. I don't really know how far 10 is. So I'll just do it sort of in a relative way. So I'm just going to start I'm going to say I've got a vector. I'll start here. I'm going to go that far and say that that represents 10 units. Okay, and I went to the right, so that's east. Now I have to go south 5 miles, so I'm going to go about half of what I just drew. Okay, like this. Then west, so I go that same amount again. Then north 10 miles, so I try to go as far as my first line, but up. Then west 5 miles here, and then south there. Okay, and if we go start to finish, we ended up right where we started. Okay, so here it asks us, what is the magnitude of our displacement? Well, the word displacement is your start to finish distance. Okay, where did you begin? Where did you end up? And our start to finish end, our distance was 0 because we ended up exactly where we started at. Okay. All right, so I'm going to end this video here. There's going to be a part 2 where we'll talk about components. Okay, so I'm try and keep these short and sweet if I can.